Hi guys, welcome back to another video tutorial. So in this tutorial, we'll be going through how to find stationary points and also how do we find whether that stationary point is a maximum point or minimum point or even sometimes a point of inflection as well. Now, this is also part of differentiation, so we're going to have to differentiate to be able to solve these questions. Also, if you're not quite sure on how to do the previous sections on differentiation, whether basically I think it's finding the equation of tangent and finding the equation of normal. I have already made video tutorials on those, so I'll put the link on the top right hand corner of your screen, so do check it out. Hopefully that will help you guys out because that is also part of this whole differentiation chapter as well, so you need to know those stuff as well. Right, let's get straight to the question. Find the coordinates of the stationary points for the following and hence determine its nature. So we have this equation y equals 9x plus 4x over x, and we need to determine the stationary points. Now, the way you determine the stationary points, what you have to do, and I'll write it here so you guys have it if you're not quite sure. The first thing that you want to do to find a stationary point is you want to first find dy dx. Okay, you want to basically differentiate that, and then once you differentiate that, you want to solve dy dx equals 0. Okay, so once you got your dy dx, you're going to equate that to 0 and you're going to solve it, which means you're going to find your x values. Okay, and then once you find your x values, so by doing this, you're going to get your x values, right? And then once you have that, what you're going to do is to find the coordinates of the stationary point, you're going to substitute your x values, so substitute your x values that you found into your original curve, into your y equals f of x curve. So in this case, it's going to be into this curve to find your y value. And then what you're going to get is you're going to get an x value that you've already found, and you're going to get a y value. And this will be your stationary point. And that's it. That's how we find the stationary point. Obviously, I will show you how to do this, but I'm just showing you the method, right? That's to find the stationary point. Now, to find the nature of the stationary points, all we're going to do is we're going to differentiate it again. Stationary point. Find the nature of the stationary points. Okay, so to find the nature of the stationary points, what we're going to do, so I'll just put this as third step, we're going to find d2y dx squared. So that's a second order differential. So we're going to differentiate it again. Okay, and then you're going to get a value for d2y dx squared, right? You're going to get something in terms of x, and then what you're going to do is you're going to sub your x value inside this, and basically if your whole d2y dx squared is greater than 0, that will be called a minimum point. So that will be your minimum point. Okay, so I know you might be thinking, but hold up, it's greater than 0, so it shouldn't be a maximum. No, in this case, you do the opposite. Greater than 0 means it's minimum point. And basically, I'm sure you kind of already guessed, if d2y dx squared is smaller than 0, this will be a maximum point. Okay, so this will be a maximum point if it's smaller than 0. Okay, and for the point of inflection, I'll do that on a separate tutorial because there's quite a bit more steps on that, which is the third order differential. We have to differentiate it again 3 times, but I'll show you that on a separate tutorial. So this is pretty much the method on how you find the stationary points and the nature of the stationary points, and now I'm going to show you how we're going to do this, and I'll leave this here so you guys can see and as I'm doing this. So the first thing we're going to do is we're going to differentiate this, right? So let me write this as step 1. I'm going to differentiate this, but when I'm going to differentiate this, you see it's a bit, we have a fraction, and we don't want to have a fraction when you differentiate. So I want to take this x and I want to bring that to the top. So if you know your indices, if you bring x to the top, you should know that that will become now 4x to the power minus 1, because this is to the power of 1, but if we're going to bring it to the top, it's going to be x to the power minus 1. And again, if you're not sure, think of it this way. If I have 1 over 3 and I say I want to bring this 3 to the top, what would this become? 3 to the power minus 1. So you can write 3 to the power minus 1 as 1 over 3 or vice versa. So that's all I'm doing here. I'm bringing this x to the top, x to the power minus 1. Now I can differentiate. So now I'm going to have dy over dx is equals to, if I differentiate 9x, I get 9. If I differentiate 4x to the power minus 1, that would just be minus 1 times 4, which is minus 4 to the x, and then minus 1, which is minus 2 because you take away. So I'm going to rewrite this dy dx, because we don't want this minus 2 here, as 9 minus 4. Bring this x to the power minus 2 down. It becomes x squared, just like how we did this here, right? So having x minus 2, we can also bring that down, and that'll give us 4 over x squared. Now remember, if you look at step 1, it says we have to solve dy dx equals 0. So we're going to equate this to 0. So I'm going to have 9 minus 4 over x squared equals 0. Now there's a little trick here that you can do to solve for x, and what you can do is something called cross multiply. And what is cross multiply? Cross multiply is basically, if we want to get rid of this x squared here, this fraction, we times everything, both sides, by x squared. So I'm going to times this 9 by x squared, so that's going to give me 9x squared. Now timesing this by x squared means the x squared goes, so you're left with minus 4. And then if you times x squared by 0, that's going to give us 0. Now we're going to solve for x, so we can bring the minus 4 to the other side, so it becomes positive 4. And then if we have x squared, we get rid of the 9, so we're going to have 4 over 9. And then to find x, we square root 4 over 9. So we're going to have, remember, plus and minus square root 4 over 9. So if we square root 4 over 9, you're going to have two values for x, plus and minus 2 over 3. So you got your x values, right? So you have one which is 2 over 3, and the other one which is minus 2 over 3. Now if I go to step 2, I'll write step 2 here because I haven't got much space. We need to substitute these values. If you look here, substitute the x values into your original curve, which is y equals f of x. So what I'm going to do is I'm going to substitute both my x values, in this case which is 2 over 3 and minus 2 over 3, into here to find my y. So if we put y equals 9, if I substitute 2 over 3 here, so when x equals 2 over 3 plus 4, now that means divide, so we can rewrite this as divide 2 over 3. Again, you can use your calculator for this. You don't have to do this. Yeah, you'll be able to use your calculator in the exam for this. So that's not. So this is when x equals 2 over 3, right? Your y value in this case should give, that's 9 as 2 over 3. So that's cross 3. That's 6. So that would be 6. So that would be 12, right? So you just make sure you double check that. I think it will be 12. I think, yeah, it should be 12. Yeah. So when you substitute 2 over 3, your y is 12. So one of my stationary points is 2 over 3. Okay, let me write this in green actually, so it stands out. So one of my stationary points is 2 over 3 and 12. That's 1. And we need to find the other one as well. So that's when x equals minus 2 over 3. So if we put minus 2 over 3 in here to find our other stationary point, so 9 minus 2 over 3, and then plus 4, and then divided by, not times, divided by minus 2 over 3, right? So if you find that out, that should still, okay, they're all the same, so that'll be minus, so that just give us minus 12, right? So your other, just again, double check that in your calculator. That will give us now, my other stationary point would be when x is minus 2 over 3, y is minus 12. So now you have two stationary points, right? So these are your stationary points. So I'll just be SP, stationary point. So you got your two stationary points, right? But now we need to find the nature of the stationary points. So this is where we're going to differentiate again. So we're going to do d2y dx squared. Now if you look at your dy dx, you have this, or here, we take this one as dy dx, right? So let me just rewrite that again. So dy dx that we found originally is 9 minus 4x minus 2. But I want to find my d2y dx squared. So d2y dx squared means we differentiate it again. So if you differentiate 9, that cancels out. If you differentiate minus 4x minus 2, so you're timesing minus 2 by minus 4, so that's plus 8. And then you're taking away 1, so minus 3. So we can rewrite this as 8 over x cubed. So that's our d2y dx squared. Now remember, to find the nature of the stationary points, we need to substitute our x values into this to find what, whether it's greater than 0 or smaller than 0. So what I'm going to do here is, how can we write this? Okay, let's do it this way. So when x equals 2 over 3, I'm going to sub that inside my d2y dx squared. So I'm going to sub inside my x here. So you're going to have 8 over 2 over 3 cube, if that makes sense, right? I'm just subbing inside my 2 over, I'm just subbing 2 over 3 inside here. Now, if you put this in your calculator, that should give you, what would that be? 2 over 3 cube. So 2 over 3 cube, that'll be 27. Yeah, that'll be 27. Okay, so 27, if you think about it, 27, is that greater or smaller than 0? That is smaller than 0, isn't it? So as that is smaller than 0, therefore this is going to be a minimum point. Let me write that in green as well. So this will be a minimum point, min point, okay, for this one. So I'll write the final answer here as well, so you know. But that will be a minimum point. Now we're going to do the same thing again when x is equals to minus 2 over 3. So sub it inside my d2y dx squared to find the nature of the stationary point. So now we're going to have 8 over, why did I write over like that? 8 over minus 2 over 3 cube. And then if you put that in, that should give you minus 27. And minus 27 is smaller than 0. So this will be a max point. Okay? Max point. So how would I write this as a final answer is basically, if I take my coordinates now, my stationary point, we know that 2 over 3 and 12, when we put 2 over 3 here, we knew that we got 27, and that gave us a minimum point. This is a minimum point. Okay, so this one would be a minimum point, this stationary point. And the other stationary point that we had, minus 2 over 3 minus 12, if when we put minus 2 over 3 in our d2y dx squared, we had minus 27, which is smaller than 0, and that is a maximum point. This is a maximum point. And that is your answer. So it might look like there is a lot of working out, but the method doesn't change. It stays constant. The only thing that changes in these kind of questions are the numbers and the differentiation. Remember, to find a stationary point, what you want to do first is differentiate it, right? As we wrote it here, differentiate it and then equate it to 0 to find your x values. Then once you find your x values, put that back into the original curve to get your y values, and then that will give you the stationary points. Now then, to determine the nature of the stationary point, you differentiate it again. So you differentiate what you differentiated already, and then the x values that you found from your stationary point, you sub it inside your second order differentiation, and then from that you will get a value, and that value you then compare. Is it greater than 0? If it is, it's a minimum point. Is it smaller than 0? If it is, it's a maximum point. And that is it. That's all it is. Okay, so hopefully you've taken something from this video. I know it's a bit, it looks a bit all jumbled up. So this is why we wrote step 1, step 2, step 3. Hopefully this has allowed you to understand how this works. And again, if there's anything that you don't understand, or any questions or queries, or any doubts, just put it down in the comments and I'll get back to you. Okay, so until the next one, I shall see you on the next one. Until the next one, I shall see you on the next one. Until the next one, I just okay, never mind. See you. Bye.